Greetings everyone. My name is Ajaz Sayed and I'm a master student at IUPUI and I'm presenting my final report for uh, failure analysis of a connecting rod, which is my project. So let's start. Uh, to give a little background, connecting rod is one of the main components of the engine, which connects the piston to the crankshaft and converts the reciprocal motion of the piston into the rotation of the crankshaft. The connecting rod must be sturdy enough to withstand the piston force during the combustion cycle. During its life expectancy, it faces a great deal of tensile and compressive loads. Connecting rod consists of small end shank and big end shank. The piston is linked by a gudgeon pin or wrist pin to small end of the connecting rod, and the big end of the connecting rod attaches the crank pin on the crankshaft. Connecting rod configuration depends on the engine speed. High engine speeds use I-section connecting rod, and low-speed engines use circular cross-section connecting rods. Steel and aluminum are the most used materials for producing the connecting rod. Certain materials such as titanium alloy, magnesium alloy, beryllium are also used in connecting rod production. Moving on, this is a basic diagram of a connecting rod and how actually the connecting rod works in an IC engine setup or assembly. So we can see here that we have a crank here, and the crank pin is attached to a connecting rod, which is in turn attached to the cylinder or the sliding block. So when this moves, it transfers the motion uh, to the crankshaft here, and the forces acting on the connecting rod are shown with the help of this diagram. There are basically four types of principal forces which act on the connecting rod. The first one is force on piston due to gas pressure and inertia of reciprocating parts. Force due to inertia of the connecting rod. Force due to friction of the piston and piston rings. And lastly, force due to friction of the piston pin and crank pin bearing. Moving on. Objective. The main objective of this study or this project was to do a fatigue analysis of an engine connecting rod, and to find out the fatigue, life, and safety factors. Uh, the connecting rod was subjected to different types of loads, which is constant amplitude and cyclic loading. Even though this is a very generic project, but I did not find uh, many projects or many research, small scale research done on a cyclic loading fatigue of connecting rod. So even though people might have done it, I have not came across that. So I have attempted to do this in this study, and the rod was designed in SolidWorks first, and then the analysis was done on ANSYS. This is the FA model and mesh of the connecting rod. My SolidWorks file was corrupted, so I had to use a generic file for this. The governing equation for calculating forces are given in the slide. The main are the forces acting on piston, which is uh, F of gas plus F of inertia minus F of friction. Force acting on connecting rod can be given by the cosine, by the ratio of force acting on the uh, cylinder divided by cosine of the angle. Moving on, these are the basic parameters I've considered while designing an analysis of the connecting rod. The wood diameter of the engine was 100, sorry, the cylinder was 100 mm. The mass, the factor of safety, Young's modulus was considered to be 2.1 times 10 power 5, Poisson's ratio, etc. It's all given here, and one can see the boundary conditions. Boundary conditions were uh, two boundary conditions were applied here. In order to limit the displacement and rotation of the rigid body, the bolts hold and the small end at the both ends of the connecting rods are fully restrained. In other words, the pinhole, that is the inner surface of the small circle, is completely fixed, and the cylindrical constraint is applied on the inner surface of the two sides of the large semicircle, and the radial direction is fixed, and the circumferential and axial freedom. Fatigue analysis. Then fatigue analysis was performed on the connecting rod by two types of loading. One is constant and the other one is cyclic. The cause of fatigue is related to the repeated loading, and fatigue usually increases to categories such as high cycle fatigue and low cycle fatigue. First, this fatigue analysis tool was set up, and the fatigue strength coefficient was set to 0.8. The coefficient can be used to modify the difference between fatigue test and computer simulation, and the other effects of the average stress can be considered. The design life of the safety factor was set to 1 into 10 power minus 6 cycles because the rod is at a high cycle fatigue problem, that is, there is no plastic deformation under the action of the external load. So the analysis type is the stress type. It can be seen that the minimum factor of safety of 1.21 is, which is greater than 1. We can see that we found out that on our parameters that the structure was safe. It can be seen from the figure that the maximum ratio is 0.985953 and the minimum value is negative 0.999, which can be used as an auxiliary to determine whether the stress strain in the key is similar to that of an experimental condition. Material properties used here can be made from various grades. Uh, as a connecting rod can be made from various different types of materials: structural steel, aluminum, and titanium. We have used steel here. Steel rods are mostly widely produced and used type of connecting rods. Their application are best for daily drivers and endurance racing due to high strength and long fatigue life. Performance steel rods can be made from 4340 and even 300 M grade steel. The tensile strength, yield strength, and the hardness of 4340 steel depends on the temperature at which the steel is forged and how the steel is heat treated. And coming on the results and conclusion, because my analysis was not perfect, I just attempted it. So I had to take reference from a lot of material. I got to find out that the number of cycles of failure, when the number of cycles reaches the number of failures, the life is exhausted and the failure is achieved. The frequency of the load is at least 87 times, and the most cyclic frequencies are low average stress and low stress amplitude. It has been found that the strength and the connecting rod meets the requirement of the use from the point of view of the statics. These are the reference of my studies, and thank you for watching.